Hello, everyone. This is Dr. Wen. Here is the question. If square root of x equals 1 over square root of a minus square root of a, can you find square root of 4x plus x squared? This is a given condition. We want to find the square root of something equals what? So the general idea is what? Can we rewrite inside part as something square? So here we consider inside part first. Can we rewrite this as something square? Here's the technique. 4x plus x squared, we factor 1x out. That's x times 4 plus x. Then plug in this given condition, square root. What is the relationship in between square root of x and x? Square root of x, then square is x. For this given condition, we can see that square root of a, we can assume a is bigger than or equal to 0 and cannot be 0 because we have denominator here. So a is bigger than 0. Plug in here. So x is square root of x squared. That's square. That's square root of x. That's given here. And 4 is here. And this is square root of x. Then square, that's x. Keep this here and simplify inside part of the second term. That's 4. 1 over square root of a minus square root of a squared equals first term squared, that's 1 over square root of a squared, that's 1 over a, minus 2 times cross term, 1 over square root of a times square root of a. 1 over square root of a times square root of a, square root of a cancel each other. You only have 2 left, plus the second term square. Square root of a squared, that's a. Simplify this, we have here, Keep the same here. So that's 1 over a. 4 minus 2 is 2. Now we have a here. Now what is this? It's this. Let's explain to you. Here's the pencil. Now, this is 1 over square root of a plus square root of a squared equals the first term square plus 2 times the first term times the second term, then the second term square, add. So here, first term square, that's 1 over square root of a squared, it's 1 over a. Crossing term, 2 times 1 over square root of a times square root of a, square root of a, square root of a, cancel each other. You only have 2 left. And here, square root of a, then square, that's a. Now, we can see we are here. Take the power 2 out. Put the 2 factors together. We do this. Can you see something special? A minus b. A plus b. Do you know the difference formula for squares? Yes, that's equals a squared minus b squared. So the first term square, that's 1 over a. The second term square, that's a. So what we have, 4x plus x squared equals 1 over a minus a, then square. we summarize the result here. Okay. Then what do we want to find? We want to find this one. That means we want to find this. We have the result for inside part, just plug in. Plug in here, you have here. Can we cancel this 2 and square root directly? No, because we have 2 possible answers. One is negative, one is positive. So the square root outcome cannot be negative, has to be positive. We always put absolute value sign here. If you have a value, you just plug in and take the absolute value. Now equals 1 over a minus a. Why we can write down this way? That means we know that inside part A is bigger than or equal to 0. You may ask why, right? Why? Now look at this given condition. This is a given condition. From this given condition that we know that a is bigger than 0 in the denominator, right? This part bigger than or equal to 0, that means 1 over square root a bigger than or equal to square root a. Just to move the negative term to the right-hand side of the inequality sign. Right? We have this here. Continue to simplify this. Square both sides, because left-hand side, right-hand side, both are positive. Then we can square both sides. If one is negative, one is positive, you cannot do that. So if we square left-hand side, that's 1 over a. If we square right-hand side, that's a. That means 1 over a is bigger than or equal to a. So 1 over a is bigger than or equal to a. So that means this number is bigger than this number. So the difference should be positive inside part. So this is positive at least 0. This is the proof. We have done, this is positive. So this is the answer. That's all. Thanks for watching and see you next time.